So welcome to the episode 11 in hexadecimal of Debugging TV Frames program. You can type your questions during this episode. If I can't answer particular questions now, I then post answers on the website debugging.tv. Actually, this is the first session where I would be doing Windows and Mac OS X dump analysis, switching between two computers, so please expect some glitches if there are any. During this episode, we briefly discuss topics such as on this list. One of the tasks we face is to get stack region boundaries to dump stack contents with symbols to see possible execution residue, such as traces of past execution histories, and sometimes to reconstruct stack trace manually. So first of all, I switch now to I opened some crash dump with several threads. I list all threads, and just I show you how to get stack trace boundaries. So traditional approach is to use thread environment block command and either specify an address or switch to a particular thread and then use WinDbg command without any parameter. So let's inspect this thread environment block for thread number 3, and what we get, stack limit, the beginning of stack region, and stack base, the end of stack region. So we can use these numbers, for example, to dump stack. So that's what we did. We see function calls on this stack trace. So I put all this on this slide with some color highlighting. Unfortunately, if we face the same task for Mac OS X, we don't have the same command like thread environment block. So how do we do that? So now I switch to Mac OS X. So what I do, I switch to Mac OS X. Let's me So what we see is terminal window. So I already created core dump with multiple threads, and I open it now. So we see 3 threads. So let's switch to thread number 1, for example. Well, actually we are already there, so just in case we switch to this thread, So we print, so backtrace is this one. We print stack pointer value. This is this one. So we now list all sections. So we list all sections and use this address to find any similar address region. So it looks like this one. Let's double check. Actually, more likely this one. No, not this one. So it's 00. I think this one. So it's 65. So it starts with 657FFF 6500. More likely this one. Let's double check again and see. Yeah, more likely like this one. And what we do, we dump, say, I think this one is more appropriate. So this one, the end of, so this is our stack trace region. So we copy this address and say, and if we dump the last 250 addresses, what we get some execution residual. So start, main, sleep. So all this familiar from backtrace. And if we look at stack trace, we could even see we can do some manual stack reconstruction like this address BA60 point to this one sleep, and here BA0 point to main, and main, this address points to start. So we can even do some manual stack trace reconstruction. So and the same can be done for any other threads. So let's see thread 2. Here we can print stack pointer and try to find on section map. Now we go back to Windows. So first of all, I put some commands on slide for macro 6 with color highlighting. And we can use the same method for Windows. Take the value of stack pointer and use address command. So for thread number 3, we get stack region boundaries. And if we switch to any other thread, say thread number 1, and repeat the same command, we get different stack region boundaries and use these values to dump stack region. So here I put some thoughts on possible patterns. You know that software construction has lots of patterns, including analysis, architectural design, implementation, and usage. And the same can be done for software post-construction phase, for diagnostics and debugging. Also, in a few days starts an accelerated Windows memory dump analysis training. This is our usual ban add slide at the end of debugging sessions, debugging TV sessions. So the next week starts the first accelerated macOS 6 training, and some spaces are still available. In September, we have the new free webinar on systemic software diagnostics, and also we plan accelerated .NET training with added new 64-bit exercises and also advanced Windows memory dump analysis training, fully 64-bit. And October training sessions stay the same, and in November I might also add accelerated Windows memory dump analysis training because the current one is quite full. And so thank you for watching this episode. Please later check out the slides and recorded video from debugging.tv. The next episode is on the 27th of August after debugging holidays. So if you have any questions, please ask. Otherwise, see you all in August. So thank you very much for attending. Bye-bye.